Okay, a quick one today. We're going to talk about chemical properties. First, we're going to get to the phases of matter. You want to go ahead and make sure you understand these. Melting and freezing is what happens with solids and liquids. Liquid to gas is vaporization and condensation. There's a couple other words for this. Evaporation is kind of a tricky thing because evaporation has to do with the intermolecular forces based on the pressure, right? Vaporization is a better word. Um, the From solid to gas is sublimation. That's the one that shows up a lot. And then from gas to solid is deposition. But this guy likes to show up on the test because most people don't know that one. Now, this intermolecular forces thing, I put that in there, but now that I think about it, that's probably not a best description of it. The intermolecular forces are decreasing. That's What I meant by that is that the as a solid, these particles are closer together and they have just less energy, which means that they're moving less and they're more. The intermolecular forces are not strong are strong enough to hold them together. So they're really stuck together. Now, as they get more energy, they start to overcome the intermolecular forces, and liquids fill their container like so, and you get um, these particles here. Now, these could be compounds, these could be molecules, they could be formula units or atoms or whatever, or some kind of mixture. And then they overcome the intermolecular forces enough still so that the particles can break away and not be next to each other and form a gas, which means that they fill their container completely, and they're always moving around in constant motion. You remember that kinetic molecular theory, all that good stuff. So that's a real quick overview of kind of what went on in your first two chemistry classes, but we'll move on. Entropy is something that we'll get to later, but that is something that is true. That is, it is increasing as we go along, which means disorder. Think of entropy as disorder. I'll come back to that every now and throughout the year. So now, when we classify matter, we know that there are pure substances, which are either an element or a compound. Now, remember that N2, O2, and even O3 are still considered elements since they are still the same element, right? They are not a combination of elements. So, a combination of elements is a compound, all right? Now, a mixture can be homogeneous or heterogeneous. You should understand the difference between those. Aqueous solutions are going to be homogeneous because they're evenly distributed, which means that those ions are swimming around in that solution. Okay, so this is a big part right there. Now, let's see. So our TOK thought experiment. This is something I want y'all to give y'all a little think about. The ocean can be thought of as a homogeneous or a heterogeneous mixture. Explain and defend both viewpoints. So I want you to try to write down your own two viewpoints, and I'd like to discuss them in class, either in person or virtually. Let's move on. Now we need to talk about atomic structure. Now you know that there are electrons, protons, and neutrons, and they have these certain symbols. N with a N naught, P with a positive, electron is a negative, and they have these symbols right here. Now the nuclear notation that's written right here, that is the atomic number, and up here is the mass number. So the tells you everything you need to know. The electron has no mass, and IB says that an electron has no mass. So the proper word for that is, let's see, negligible. Okay. for the actual, well, it has an actual mass, but we'll just say that it is negligible. That's all they expect you to know. For proton, it has one proton, so its mass number is 1 as well. And the neutron has no protons, but it does still have some mass. So you should know what isotopes are. And isotopes can be written in a couple of different ways. Nuclear notation like this, or in hyphen notation. So hyphen notation, like this is uranium-238. This is also uranium-238. Now, this atomic number is not required to be writing, but sometimes people put it in just for fun. You can look it up on the periodic table. Now, remember that an ion is something that has more or less electrons than it's supposed to have on the periodic table. Okay, so let's do some quick examples right here. How many protons, neutrons, and electrons do each of the following have? So we have just an oxygen. Let's just say one oxygen. It is supposed to have, well, dang, I don't have the periodic table in front of me. I'm going to doubt myself. I think it has 8. Yes, 8. Protons. So oxygen should have 8 protons, but there are 3 oxygens there. So that would be 3 times 8. 3 times 8 is 24. 24 protons. And so it should have 24 electrons, but it is heavy 1 electron, so it has 25 electrons. And then it has, let's see, of the 16 protons and neutrons, 8 of them are neutrons. So there are going to be 24 neutrons as well. All right. Now this one should be a little easier. This is just a singular one, but here's nitrogen, and it has 7 protons. So 7 protons. And it is heavy 3 electrons. So it should have 7 electrons, but it is heavy 3 of them, so it actually has 10 electrons. And then it has, let's see, what is 15 minus 7? 15 minus 7 is 8. So it has 8 neutrons. All right. Now hydrogen has 1 proton. You should always know that one. And it has, let's see, it has 1 less electron than it's supposed to have, so it has 0 electrons. And then it has, what's 3 minus 1? Well, that's going to be 2 neutrons. All right, you guys can do that. Pretty simple. You'll be expected to do that on that test. And that's going to be it for today. Thanks.